Kepler wrote the New Astronomy on a subject which was a serious field of debate between the systems of Ptolemy, who puts the Earth at the center, Copernicus, who, as everyone's familiar, puts the sun at the center, almost, and another man not so familiar today named Tycho Brahe, who had the planets moving about the sun and the sun moving about the body of the Earth. Now, Kepler was a Copernican, but he does not begin the New Astronomy by laying out reasons why Copernicus's system was geometrically superior. Instead, he proves that all three of them can have their parameters adjusted to be completely geometrically equivalent, meaning that as they were understood up to his day, there would be no observation you could ever make that would determine which of the three was correct. The way the WLYM.com website explains that is to make actually identical geometric motions in the Ptolemaic, Copernican, and Tycho Brahe forms. They're then laid side by side to demonstrate that the motion is equivalent. And there's an interactive animation as well, where you can move between the three to get a real sense in your mind of the geometrical equivalence between them. Kepler's Discovery.com really screwed this one up. This is one of their biggest mistakes. Every one of the three systems is an error. The Ptolemaic system lacks the sun, which is important because that dictates how the epicycle is rotated. The Copernican system, they put a double epicycle on here, which makes the eccentricity completely unequivalent to the Ptolemaic one. And the Tycho Brahe one, they made a mistake that even a typical Wikipedia contributor probably would not have made, which is that they made Mars's orbit smaller than the orbit of the sun around the Earth. Amazing incompetence. Then in no way do they address the fact that they're actually equivalent, but they simply write, after showing these three incompetent animations, that Kepler showed that they were equivalent within a hair's breadth. A perfect example of stating something without forcing belief through an actual demonstration that creates knowledge in the mind of someone working through the website. If you didn't already believe that on your own, there'd be nothing compelling whatsoever in the website to make a case for that. The trouble of finding out where a planet is located is that the Earth's motion also affects where the planet appears to be. So at certain times when the Earth, Sun, and the planet, such as Mars, are all in a line, you're able to observe Mars and it's in the same position as the Sun would have seen it. These observations were known as oppositions. Now, if you have enough of these, you can start to piece together what the orbit looks like from the Sun's point of view. Kepler's predecessors, when doing this, all realized that the planet's speeds increase and decrease, not just from the standpoint of us on a moving Earth, but also that the planets actually do change their speeds. The way they had all explained this is through the use of what they called an equant, which is an imaginary point, a geometrical point, nothing exists there, but around this point the planets move at a constant angular speed. Since the point isn't at the center of the orbit, it means that the planets actually speed up and slow down according to this equant. So what Kepler did was he made a model that he called his vicarious hypothesis. He called it vicarious because he didn't believe that a geometric point actually caused motion. He believed that the sun was the cause of the motion of the planets. But in order to open people's minds up to that possibility, he had to show why all of his predecessors were necessarily wrong. So what he did was he made a model with their method, but doing a better job than any of them had. One of the key steps in doing this was to not make a geometric assumption that his predecessors had made. For example, Copernicus said that you have the sun, you have the center of Mars's orbit, and you have the equant. They're all on a line, and the center of Mars's orbit must lie directly between the sun and the equant. If you make that assumption, three measurements made at opposition are enough to determine the parameters of the orbit and make a model. Kepler did not make that assumption. He assumed that the center of Mars's orbit could lie anywhere on the line between the sun and the equant. And therefore, to determine a specific model, he had to use 4 observations instead of 3. And it made for a lot more work. He basically had to adjust the parameters until the model fit exactly as it could. It was an incredible success. With his model, he was correct within observational accuracy for all of the observations of Mars. However, it incorporated a distance between the sun and the center of Mars's orbit that was not in accord with actual measurements of Mars's distance from the sun. When he made that correction, then the model no longer accurately predicted where Mars would be. So the fact that this error was inescapable meant not that Kepler hadn't done a good enough job making his model, but that the method for making the model was itself fundamentally flawed. This creates an actual sensation in the mind of the idea and the foundations of astronomy actually themselves being wrong, and forces the reader of this book to be open to the idea of something else causing the motions. This opened the way to an astronomy based on causes, a physical astronomy, a new astronomy. On their webpage, they had to explain why Kepler used 4 observations to make his vicarious hypothesis. They say that he used 3 observations, because 3 points make a circle, and they used a 4th for good measure.
This plagiarism was politically motivated. It was perpetrated for the same reasons that Newton was created. This fraud could only be accepted because modern education simply passes stories down from teacher to student.
When we learned the Pythagorean theorem, I remember that one girl in the class had raised her hand and asked the teacher how he knew it was true. And his response was that that's what he had learned in school. I think that seems to continue.
The education system, the academic education system, has a lot to defend. They're probably terrified of what we're doing because it really shakes the very foundations on which, every single university education system is structured upon, which is this empirical method. It's radical empiricism, logical positivism. Kepler breaks the back of all of that. And I think they're probably terrified of that.